welcome to the Statics Tutorials. So in this video we have a frame that has three members, EDC, CBA, and then DB. DB is connected in with smooth pins here at D and B. EDC and ABC are connected here with the smooth pin. A is connected to the ground with the smooth pin, and then E is just a frictionless connection to a flat, smooth surface. So we need to find the reactions here at D and at B. So let's start off by looking at this member DB. This member DB has forces that are applied at the joints due to the reactions, but it also has a force here that's midway over. So it has more than just two forces, so it's not in either just simple compression or tension. So when we draw our free body diagram over here, we need to draw dx and a dy for that pin connection, and then over at B, a bx and a by for that pin connection, and then show our 300-pound applied load. We can do a sum of moments around D, so we have our negative 300 times our 1 foot. We calculate the 1 foot in that this whole height is 4 feet. We're 2 feet up, so we're going half the height. So we must be going half of the way over. So if this is 2 feet, then this has got to be then 1 foot and 1 foot, and then on this side 1 foot and 1 foot. So we have the 300 pounds times the 1 foot distance here. And then we have by times the 2 feet distance back over to D. The by times 2 feet gives us a positive moment, and we get that by is equal to 150 pounds. Then we can do the same thing but around B, and we get basically the same result. We get that dy is equal to 150 pounds. So dy and by just split the value of the applied load in terms of the forces in the reactions at D and B. We can do a sum of forces in the x, but we can't solve it quite yet. We get that dx plus bx is equal to 0, so dx is equal to minus bx. We can draw also the free body diagram for the overall body, so this would be EDCBA, all connected. Because we have it connected, we're not going to show the forces at D and B, and we're not going to show the forces at A because they're internal to this free body diagram. But what this free body will allow us to do is our sum of moments at A. So when we do that, we have EY times the 4 foot distance here, and that's a negative moment. And then we have the 300 pounds times the 2 foot distance here, which is a positive moment. And we can solve for EY and get that it's 150 pounds. Then we can do a free body diagram for EDC. So we can show the 150 pounds that we just calculated for EY. For DY, because this is the other side of the connection, we need to remember that the reactions are equal and opposite. So dy is going up over here, dy is going to be going down over here. But we already solved for dy and we got the 150, so we can plug in the 150 here. dx, we have it going in this direction over here, so we're going to do equal and opposite and put dx going in this direction over here. The x and cy, we haven't drawn those already, so I'm just going to put cx going in positive x and cy in the positive y. Then we can do sum of moments about c, so we have dx times the 2 foot vertical distance, that's a negative moment about c. Then we have our 150 pounds times our 1 foot distance. That's a positive moment around C. And then we have our negative 150 pounds times our 2 feet distance, which is also negative. So we get that dx is equal to negative 75. We already have this relationship that dx is equal to negative bx, and so bx is equal to 75. So with this one, this is a frame because it's not moving. But the analysis is the same basically with the frame and the machine type problems. And you can see how with the pair of pliers that we did in the previous video, we only had the 2 members. It really wasn't that complicated, but now just adding a third member really makes it a lot more complicated. And some of these frames can include several members, and so you can sometimes take pages and pages of calculations. But just keep in mind you can draw all these different free body diagrams, and then when you're drawing the same point on two different free body diagrams, make sure if they're the different sides of the connection that you do that equal and opposite. Otherwise, you're introducing sign errors into your calculations. Thanks for watching.